Hello, my name is Ioana Kulik, and in this tutorial, we will work with maths and variables inside ValueGene Studio to control our Raspberry Pi Pico. We will look into how variables are represented in ValueGene Studio when using blocks. We will look into the variable scopes and array, and then we will write some applications that deal with minimum and maximum values. We will build a simple state machine, and we will compute a moving average. First of all, let's look at the variable scope. And it's important to keep in mind that we use this blocks programming language that translates to Python code. And the syntax that we are going to look into is specific to Python, where all variables are basically declared global. But we can notice a slight difference between the two declarations. We have first an example where we have a function that adds two numbers, but the two numbers, basically the two parameters x and y, are declared only inside the function scope. We can notice that inside the main loop, the while block, there's no x or y. X or y are only specific to the function. On the other hand, we have the second example, where we have the same function that adds two values, but gets the values from the global scope. X and y are declared in the while loop, which is the global scope, and the function retrieves these values from within the global scope. Further on, we move to array variables. Arrays is like a group of elements. We see here that they are basically lists. In ValueGene Studio, you can find them under the lists section. And an array is like a list with a finite number of elements. In the example on the left, we have an array having 5 elements. So basically the size of the array is 5. Because it is important to keep in mind that an array or a list has a size, which is basically the number of elements inside this list. Also, each element in an array can be retrieved individually based on their position. So we have the element at position 0, the element at position 1, and so on. What is very important to keep in mind is that under Blockly, the position starts at 1. So we have the first element will be the element on position 1, the second element will have position 2, and so on. This is specific to Blockly and to ValueGene Studio. What you can see is that under the list category, we have a set of blocks that allow us to do a lot of complex operations with lists. First, we can create static lists, we can retrieve length of lists, and we can retrieve elements, as we've seen, accessed individually. Basically, we retrieve an element based on its position. Also, we can find a block under the maths category that allows us to compute directly the sum of all the elements in a list. And under the loops category, we have a block that allows us to iterate through a list. And we will see this in the next slide. Here we want to compute the sum of the elements inside an array. And we have 3 options to do that. First of all, we declare the array. We declare a variable called array. And the variable is basically a list with 5 elements. And we want to compute the sum of the elements in 3 ways. First of all, we compute the sum by iterating each of the elements in the array. We set the sum variable to 0 because we have no element inside of it. We have not added yet any element to the sum. And then we use the for each item in lists. Basically, this block gives us the value for each element one by one. And this value is stored under the I variable. So we set the sum to be equal to the previously computed sum. And then we add the new element that the for each block retrieves us. Basically, for each will iterate 5 times because we have a list with the length of 5. And for I, we will have first the value of the first element in the list, then of the second element, and so on. And we do this 5 times. Basically, we add the newer value to the already computed sum. Then we have a second approach. We take a second variable called second sum. Again, we set it to 0. And now we use a count block that takes the variable j and basically sets j to have values starting from 1 to 5. And we increment each value by 1. So this count block again will iterate 5 times, as long as j has the value 1, then j has the value 2, j has the value 3, 4, and 5. For the second sum, we do the same computation. We add the previously computed value, the sum, with the newer element. And now we retrieve the element by position. We retrieve the element on position 1, retrieve the element on position 2, and so on. And the third option, the most straightforward option, is to use the sum of block that you can see here. You can find this block under the math section. Next, we move to a more complex application where we want to compute the minimum and the maximum values that we read using a potentiometer. We can see here that we have a potentiometer from where we will read values. We have an LED and the button. We want our application to start with the LED turned on and start computing minimum and maximum values that we will scale between 0 and 100. And once we press the button that you can see in the schematic, we want the application to stop computing and show us the results. Here we can see the application that we have built. First of all, we initialize the pin 26 as the pin where we have the potentiometer connected to, is the ADC pin. Then we have pin 1 for the button. The button is connected on pin 1, and on GPIO 0 we have the LED. First, we set the max and the min variables because we will read numbers scaled to 0, from 0 to 100. We set max to 0 and we set min to 100 because basically we don't want to influence in any way our computation. So maximum is set to the minimum number that we can read, and the minimum is set to the maximum number that we can read. This way, when we will try to compare the values that we read to these values, this will not impact our comparison. Next, we set high, pin 0, because we want to have the LED turned on. And then we start repeating the readings until the button is pressed. For each reading we do from the potentiometer, we scale it to have values between 0 and 100. And then we do some simple comparisons. Basically, if the value we read is lower than the minimum that we have computed so far, we store this value under the minimum variable because this is the lowest we have read so far. Then, if the value we read is higher than the maximum we have read so far, we set this value under the maximum variable because this is the maximum value we have read so far. And we keep on doing this. Basically, for every value that we read, we compare it to the minimum and the maximum. And if it's higher or minimum than one of them, then we store under that variable. This whole loop will stop once we press the button. And once we press the button, we also set the LED to low, and we write on screen the two computed values. For the next application, we want to build a simple state machine. We want to store the state of our LED based on the button we press. We have the LED connected on GPIO 0, and we want the LED to be on when the button is pressed and off when the button is released. We also want to print a message each time the LED changes its status, but it's important to keep in mind that we want to print this message only on status changed. This is similar to some examples we did in the previous video. Here we have the application. When we initialize pin 1 as the pin where the button is connected, and we have the state variable. We basically have two states. The state where the button is pressed and the LED is on, and the state where the button is released and the LED is off. We number the states with 1 and 2. So we set our state variable to 0 first because it's neither of them. Then we go into the while loop and try to read the values from the button. These are set under pushed variable. If the pushed variable is true, basically we have the button pressed and the state is not 1, so we have never been in the state where the button is pressed, we set the LED to high, And then we also write on the screen that the LED was turned on. And we change the variable state to 1, because now we find ourselves in state 1. Then we check if the button was released, which sends us to state 2. And if we haven't been previously in state 2, we set the LED to off and print this on the screen. We do this forever, but basically what we can see is that using the state variable, our code prints the change of the state only once. We ensure that we don't write for each reading the message regarding the LED on or off. For the last example, we want to compute the moving average. It is important to know that for most of the measurements that we will do, we want to compute only the average, like the mean value. And here we have the example of how it is computed. So we have the mean of 10 consecutive measurements. We see here that we have an array that has 10 values that have been read consecutively, and we compute the mean. Basically, we sum all the 10 values, and then we divide by the number of values we have, which is 10 in our example. If we do a new measurement, the first measurement, like the oldest one, will be excluded from the array, and the newest will be added to the array. And we have a new mean that we have to compute. This leads us to a recursive implementation, and the formula is the following. The new mean for each new measurement will be equal to the old mean, to which we add the new value minus the old value divided by the array size. Basically, from the whole mean that we computed, we need to delete the oldest value, we need to add the newest value, but this needs to be scaled to the number of elements in the array because we have a mean. In our example, we will compute the moving average of an analog signal using a potentiometer. Now for the application that we have to build, first of all, we initialize pin 26 as an ADC. This is the pin where we have the potentiometer connected to. Then we set the mean value to 0 because of how we have done no readings. And we set our array of 10 elements having only 0 values because again we have done no reading. And now we go to the while loop when we start reading values. But first of all, it's important to keep in mind that we need to store somewhere the oldest value. The oldest value will be the value on position 10 in our list. So we set this value, we retrieve this value using the inListGet block, and we set it to the oldest value variable. Then we start on iterating the list. And we have to do the following. We have to shift all the elements. We have to make sure that element on position 9 gets on position 10, the element on position 8 gets on the position 9, the element on the position 7 gets on position 8, and so on. For this, we have this count block where we do this shifting. Now, on the first position, we have the same element as the one on position 2. And for the first position, we need to store the reading that we do. And this is what we do with the block inList set value. We set the value that we read on the first position. Then we apply the formula that we discussed before to compute the new mean. The mean is related to the mean that we computed before and to the oldest value that we have read. Now, once that we have the value, the new mean, we print it on the screen using the serial console, and we do the reading again. And again, we will need to shift the values to compute the new mean, and so on. In this video, we looked into variables and how we can use lists to write more complex applications. Thank you.